Hello friends, this video on chemical bonding part 23 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched part 1 to part 22. In case of sp2 hybridization, 1s and 2p orbitals overlap or 2p orbitals merge and rearrange to form how many sp2 hybridization? 3. Obviously, why? Because 1 plus 2 is 3, so it forms 3 sp2 hybridized orbitals of equivalent energy and shape. Correct? So 1s and 2p, it is like 1s, 1p, 1p, it forms something like this, right? 3 orbitals. Here all boron and carbon compound with double bond goes sp2 hybridization. Carbon with double bond, for example, ethene. This goes for sp2 hybridization. So the same thing which I have drawn there. So 1s, 1p, 1p, all combined to form sp2 hybridization. If you see, there are 3 orbitals, 3 sp2 hybrid orbitals. All are equal shape and energy, and they are 120 degree. And the shape is trigonal planar. Correct? Let's take example of BF3. So boron I have of 1s2, 2s2, 2p. Correct? So this is my electronic configuration of boron. So I am just writing the outermost one, the valence one, 2s2, 2p1. Right? It has got 2 and it has got 1. So now what will happen is the same thing if you see here. So this the outermost, I am just drawing the one, the yellow is the outermost valence cell. So 2s will have 2 electrons and one of the p will have 1 electron, the other 2p will be empty. So I made it blue because there is no electron there. This yellow one p orbital has 1 electron and this yellow spherical s orbital has 2 electrons. This is 2s, this is 2p. And they are all 2p, but these are not having any electrons, so I made it blue. Now what will happen is one electron will move from s to p, and now they will form sp2 hybridized. Note this, this was 2s, this was 2p, this was 2p, and this was 2p. Now one electron moved from s to p, right? If you want, I can draw you once again. So this from s it went to p, now it is sp2 hybrid orbitals. So if you see, only 3 orbitals took part in this, so we got sp2 hybrid orbitals. We'll see in the demo how it looks like. So I have 3 fluorine molecules coming and I have this boron here. I'll just put boron here actually. 3 fluorine molecules coming, and now if you see, this will get hybridized. So this becomes sp2, this becomes sp2, and this becomes sp2. Right? The third p is not taking part in this hybridization, so it is as it is. And now each of these sp2 hybrid orbital will have 1 electron each, so you'll see 1 electron each here. And the fluorine molecule which has got also has 1 electron because they are unpaired. So since these are all unpaired, this is unpaired orbital, this is unpaired orbital, so there will be overlap, right? This fluorine will overlap with the boron sp2 hybridized orbital, because this orbital and this orbital both has unpaired electron. Similarly, in this case also, this is my fluorine and this is my boron sp2 hybridized orbital. So both have 1 electron each, so they'll overlap. Here also, if you see, the red one is the electron of the fluorine and the blue one is the electron of the sp2 orbital of boron, and they'll overlap and they'll form BF3. And the shape also which we see for the BF3 experimentally is trigonal planar. The same thing we can prove using Vesper theory also. If you see, this is my bromine, which have 3 electrons in the outermost shell, and it has 2 fluorines, 3 fluorines. So it is a molecule which has 3 bond pair and zero lone pair, so it is trigonal planar, right? So according to Vesper also, if you see, this is my blue bromine, this is 3-fluorine, and there is no lone pair in the bromine, so it gets the trigonal planar shape. Similarly here also with the valence bond theory also we get the same shape, right? But the approach is different to explain, because BF3 is trigonal planar is experimentally proven, right? And why it is trigonal planar is explained by two different theory. One was the VSEPR theory and the other is valence bond theory. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.